All right, hey guys. This is going to be Mikrotik as the troubleshooting tool, and we'll jump into that here in just a second. But first, the important part where I tell you who I am. I'm a guy who's got some certifications that nobody cares about. I do technology stuff for Data Center Group, mostly here in Texas. I do consulting. Most of you have probably been ignored because I also am an author for lynda.com, and they pay me way more than the other stuff does. I also have a blog at gregsowell.com, so I don't know if you guys have ever popped in there or not. Most of the people have blank stares, but I do some kind of educational stuff in there, and I'd like to do more of it soon. You never know. I keep promising, overpromise, underdeliver. That's kind of my motto. Something else I'm sort of proud of is the Brothers Wisp, a group of guys get together and talk nonsense. We have a podcast we do twice a month. We also do it on YouTube. I can't imagine anybody wanting to watch our faces while we do it. It's somewhat bizarre. Occasionally people recognize me when I'm at a mum, not in real life, obviously. Most of us are actually here. I'm here out of Texas. Andrew Koch is he's in Australia right now. He's working on moving down here. You've got Andrew Thrift out of New Zealand. Thomas Kernak, Slovakia. He's probably over there working Unimus booth. Tom Smith out of Ireland. He's not here today. We've got Mike Hammett, Chicago, not here. JJ Boyd is right over there. Alex Hart, and I think I misspelled his name in this slide, just for you, buddy. Justin Miller, he's back there in the back of the room. Justin Wilson right here. I'm pointing these guys out because come and talk to us, shake our hands. This is the reason we come to this thing. Come and sit with us at breakfast, at lunch. Just tell us a little bit about you. That's the reason we do all this stuff, is to meet people and obviously figure out all the clever things you've done so that we can start doing those for ourselves as well. All right, so assumptions with this. You know what a Mikrotik is. You're somewhat familiar with Winbox, most of the tools, adding addresses, static routes, configuring interfaces, right? It's just mostly the basics. You don't have to have any real advanced knowledge for what we're going to kind of cover here. So using the Mikrotik as a troubleshooting tool, most people traditionally have a configuration like this, right? Where I've got an internet connection, I've got my router, and I've got my clients that hang off of it. And all the troubleshooting you're doing is actually with the router that is doing all the routing, right? If you get a call, I can't get to a website, so what do? You try it from your desk, you try and ping it from the router, do a trace route, you ask the customer for a trace route, right? But you can't really emulate their experience properly, right? You don't have any probes out there. And for the most part, I try not to log into customer servers to troubleshoot from their environment, right? I don't want any kind of liability when it comes to that sort of thing. So name that same environment, only you've got a little bit of redundancy now. I've got 2 border routers and internet connection, right? So since there's that element of redundancy, it's going to be harder to sort of troubleshoot in that environment using just the routers that are actually doing the routing, right? I could run into asymmetric routing. One of them could be eating traffic, right? And then as you increase redundancy, as you can tell, I work from a data center sort of perspective a lot of times, right? So it's 100% SLA on a lot of our infrastructure. So it's got to be as bulletproof as possible, which means there's a lot of lines on your diagram, which means a lot of complication. And it just gets a lot hairier, especially when the customer starts overlaying their own redundancy pieces, right? I don't know, is the problem in their network, in my network? Generally, I always assume it's my fault, right? If somebody calls me, I drop everything because it's my fault. Even if I know it's not my fault, it's my fault until, we're, as network engineers, we're guilty until proven innocent, I think is pretty much how it works, right? It always gets blamed up the chain. But in those scenarios, what happens if the router is actually the failure point? For whatever reason, I break natting for all the reasons Giannis just talked about. I did some incorrect firewall filtering. I configured a tunnel improperly. I have some internal routing issues, right? So if the customer says I can't reach this web resource and the only thing I have to test with is this router, and I test out from the outside, if my configuration is in the router and inside, I'm not going to be able to replicate that experience, right? I won't see that. I won't understand what's going on. Everything's fine for me, so it must be fine for everybody, when a lot of times that's not the case, right? So what do? I use Mikrotiks as probes. So in all of my data center networks and all of my MSP networks, I put a Mikrotik as close to the customer experience as I can, right? So if I have a gateway device that I hang connectivity off, I hang a HAP light off there. I love those things. They're 20 bucks. They're practically disposable for that price. Everybody in this room can afford to put a $20 device in a network for testing, and they're invaluable, right? So I get that same call. I test from my desk that's probably outside of the network, right? And if it works for me, then I go to the test Mikrotik, and I'll emulate that experience. And then I can also gather information from their border router, right? And then I can gather information from there. It just gives you a lot more points to test from, right? If everything's fine for me, and then I hop into that test router, this has happened to me before, and everywhere else in the network, everything seems fine, but I can replicate their experience, I have a problem. And I know I have a problem, right? There's no more sort of guesswork. I think this might be it, that might be it. I actually know I have a problem, right? So step one, ICMP. Can I ping it, right? Ping utility was developed in 1983. It's almost as old as me, right? And it's crazy that in kind of this networking world, our number one go-to thing is still ping, you know, but it works. And honestly, that's the first thing I usually do. Next to that is traceroute, which 1987, right? It's like they were watching Ninja Turtles programming this thing, you know, back in the day. And that's going to give you path analysis, right? And if you have a probe, you've got one more point to test from that's super close to the customer, right? So if I can test from the same gateway they're connected to and I can't emulate it, right? Everything is clean for me, then it's likely from that device in, right? And so I kind of don't have to worry about all the rest of my customers. They're probably not experiencing that same issue if I can't replicate it when I get that close to them. So it cuts a lot of the troubleshooting process out, right? I can say from this large swath in, I don't have to worry about it. So I just start looking in. So I also love it for the results it provides, right? So my test Mikrotiks, if I get somebody calling about a resource that's failed, I'll pop into those and I'll start a ping. And I'll leave them running the entire troubleshooting process, maybe the entire day. And at the end of it, I'll send them a screenshot from these devices hanging off their same gateways that show 6,000 successful pings, not a single dropped, right? The picture speaks 1,000 words sort of thing. I love the traceroute utility. All of you, this is nothing you guys don't know, right? But it creates pretty graphs. If you have upstream providers, it's really good evidence gathering for them. It's very simple for them to understand and see. A lot of times this is clearer than sending them a trace route from a command line, right? I don't know, for whatever reason, this sort of sells itself better. Everybody loves graphics, right? When you're going to your management, graphics always work better. This seems to help the carriers as well, which I always have problems with because it's never their problem, right? It's always your problem. It's never their problem. You guys have been there. You feel my pain. And with multiple gateways, this is especially useful, right? I've been in situations where gateway 1 and 2, gateway 1 I test from, it's clean, right? I can't emulate the customer experience. I don't know what they're talking about. I jump to my test probe in gateway 2, and all of a sudden there it is, right? So something's not right. You know, if 99% of your network seems clean, but then you get close to that customer, you can really get a better feel for what's going on. And it really just cuts down your troubleshooting time because I really will. I'll beat it to death until I can 100% guarantee it is not me, it is me. And so I will keep burning those resources, and I hate doing that because I'm sure just like you guys, I've got a million other things I should be doing. All right, so moving beyond ping, there's other things you can do really quickly. Testing TCP ports. So you Winbox in your Mikrotik, you SSH into it, whatever you have to. You can use the Telnet tool just to ensure that a port is open, right? So in this squished example, I connected to a web server. I just typed the word get to do a get request, and it spit out a bunch of stuff. So I know I've at least got physical connectivity, right? Some stuff could be getting munged, but three-way TCP handshakes happening, I'm getting stuff back, right? So it's kind of a really quick way to test that stuff. Especially good for plain text protocol, so you can do it with web servers. You can do it to SMTP servers, right? You can jump into an SMTP server, throw a hello edit, and it should respond back, right? So you can really quickly tell if you've just got basic connectivity. Again, this doesn't 100% duplicate the experience, but it can be just a litmus test really quickly. And you can actually use this in combination with Torch or the packet capture tool. I think David displayed that a little bit earlier, showing how to do packet captures. So you can at least see those TCP sessions going back and forth. Something else I like to do with these probes is you can VPN into them, right? So Giannis was talking about the insecurity of PPTP, L2TP. In these instances, I don't care about security. I just want to pop out of the remote device and emulate the customer experience. So create a tunnel to them, pop all of your traffic out. You can test those web resources, test RDP, test as close to being the customer as you can. Extremely useful. Use that a lot. You can also use these for test Wi-Fi probes. I use these a lot, which is great for the HAP Lite, right? I've got 4 ports, and I've got, it's only a 2 gig radio, but it's still a radio in there. I can do a scan, so I can look for open APs. I can see frequency utilization. I can see if my environment's really noisy really quick. But I can also VPN in to this device and have it connect to the Wi-Fi network, and I can emulate those customer experiences as well, right? So in this quick example video, because I'm not brave enough to do it live, I put wireless LAN 1 into a VRF. I'm going to give you the quick and dirty of VRF, virtual routing forwarding instance. Basically creates a segregated routing table in your Mikrotik. It's usually used with MPLS, right? So you can have overlapping IP space, things like that. But for this example, we're just using it to carve off the wireless interface. So it sort of is an island unto its own. Add a DHCP client on the wireless LAN interface, so it will connect just like all of your clients will. Add a masquerade rule, which Giannis says you're not supposed to do, to the wireless LAN interface, just to have your traffic and NAT out. And then we're going to have it connect to the wireless SSID. And then here's a moment of truth. If I click it and it starts playing. Yeah, there it goes. Magically squished. All right. So going into the VRF, you go IP routes, the VRF tab, and I'm naming it, it's like Wi-Fi test. And then you just add a wireless LAN interface, say, okay, that's it as far as the VRF goes. I'm done with that. It's that simple. I'm going to go to DHCP server. You guys have done this a million times, or rather DHCP client, add it to the wireless LAN interface. I'm going to go back over to IP routes, I think. No, going to firewall, add in the masquerade rule for anything going out the wireless LAN interface. I forgot what tab I was on for a second there. So out interface, wireless LAN 1, source NAT, action masquerade. So all that stuff will get natted as it heads out the door. Wireless, I'm just going to turn that on. I'd already connected it. You guys know how to connect to a wireless AP. Go to IP addresses. You can see he pulled an address, wireless LAN 1. If I go to IP routes, do it. There it is. You go over to the routes tab. You can actually see that all those interfaces that were added go into their own private routing table, Wi-Fi test. And you can just start a ping from 8.8.8, and then in the routing table entry here, you specify that VRF table, and then ping. And now the router is going to source all that stuff through the Wi-Fi instead of back through the wired network the way you're connecting. And that's actually available via traceroute as well. So here I throw in Torch just so you can actually see that it is going out the wireless LAN interface. So it truly is doing what it's supposed to. And then I switch it back over to just the main table. You see it's going out the physical Ethernet port. Nothing complicated, right? Tools. I'm going to traceroute. As you can see, you can specify an alternate routing table. Right, this way there's a couple of ways to skin the cat, right? You can do this with Mangle rules and some route manipulation. I just like this because it keeps it a little bit cleaner and easier. So here we're actually going to create the VPN tunnel and have it connect in to, we're going to use PPTP. We're going to have that jump right into the VRF. So it's exact same configuration. We're just going to add the PPTP server interface into the VRF. So as soon as you VPN in, you're now, in essence, connected just to the Wi-Fi, and all your traffic's going to dump out the Wi-Fi and then come back and go back through the tunnel, right? So you can emulate web browsing or RDP, especially useful for things like that. Or say custom applications, custom written applications, and you need to see it from that part of the network's perspective. This gives you a good outlet to do that. All right, so PPP, you enable PPTP, we create the server, and then we're just going to edit the profile and give it some addresses you shouldn't give it, 1.1.1.1 and 1.1.1.2. But for this demo, I don't really care. Here's a PPT server binding. We're going to name it PPTP Wi-Fi test. And we're going to specify the user we just created, test, so that whenever he connects to this, IP routes, should go to the VRF tab, edit it, hit the drop down, and just add that PPTP interface into the VRF. So as soon as you connect, it comes online, it's in the VRF. Let's see, I think I actually do a test as well. All right, so you can see I've connected with my laptop. The client is connected. I've pulled the IP, it's magical. And then I do a ping, and it goes through the PPTP tunnel into the VRF, and then pops out the Wi-Fi for a solid test. So it just gives you the ability to emulate kind of the exact customer experience. Did I do anything else in this? I think I do a quick torch just to show you what it looks like. That's boring though. All right, so a lot of people are going to say, I utilize out-of-band management, right? So it's just an alternate internet connection into your network. It operates the same as the previous example. Instead of having the wireless LAN interface in the VRF, you just add the physical Ethernet interface in. Operates the same. You can also use a Mikrotik sort of as a serial console server. I don't know if you guys know that. If they have a serial port, you can run that to, say, a Cisco device, a switch, a router, a Juniper, anything else that's got a serial interface. And you can kind of backdoor through that. I was going to show you an example, but it's super boring. You know what it looks like to plug a serial cable in to another device. Let's move on to some more interesting things. Do you want to see it? Oh, Lord of mercy. You got it. It is fast. So you just physically cable it in there. If it's a DB9 to RJ45, if it's a 45 to 45, you just use a rollover cable. You console, go to ports. You actually have to disable it because if it's in use, Mikrotik won't let you use it. And then you go system serial terminal, and then you say serial 0, which is what it was, and it connects right in. Control A, and then R. So a Cisco device defaults to 9600 baud. Mikrotik's default to 115200. So you have to tell it auto range, and it'll find the other device on 9600. And then when you're done, Control A and Q. That quits out. It's pretty simple. Simplistic, I should say. Let's see. Probe test Mikrotiks. This is a simple one. If you've already got them in the network, why not ping them, right? If you've got an internal network monitoring system, which everybody in here should have something, right? The Dude, NetMX, NetXMS, What's Up Gold, there's a million of them out there. Libra NMS, anything that can ping a device, you should be doing that internally. In my networks, I also utilize external monitoring systems that have geographical diversity. So from 7 spots in the US, I ping all of my devices, right? So I don't want to just ping my routers. I just want to ping my gateways and my borders. I want to ping through those devices, right? So, you know, order of operation in a router is always serve packets first, right? Everything else is second. So if a router comes into duress, right, if it's under load, the last thing it really cares about is answering your pings, right? So if you're pinging your border router and it is, say, churning away, it's probably passing packets just fine, but it might drop some ICMP. And that's not uncommon when you do a trace route to see some packet loss in the chain, but complete connectivity and everything's running smooth, right? Because ICMP just has a lower priority in the system, right? So you actually want to ping all the way through your devices to some known stable probe point to really say, are things running the way they should be, right? And as well as if you get these guys in an emulated experience to the customer, you know truly that, or not 100% truly, but as close as you can, that customer experience looks like this, right? As opposed to sort of guessing. Gives you just more points. So that's a neat freebie. If you've already got them in there, why not utilize them as much as you can? Let's see, layer 2 troubleshooting. This is one I don't think most people know, that you can use a Mikrotik that's out of band to actually troubleshoot layer 2 infrastructure. Communications issue, say in this example, layer 2, you have a server and a test client on a single switch, and they're having communications problem of some sort, right? You could do a packet capture on the test client, you could do a packet capture on the server sometimes, right? But maybe you don't own that portion of the infrastructure, you're just the network guy, and they're, right, it's always the network. I've literally got a shirt that says it's not the network, right? But you don't control those two end pieces, so you can't really get in there. Say this is a catalyst switch, right? I can't really do a packet capture on a Cisco switch. You know, I mean, you can on some stuff like Nexus and things like that, but if it's a regular catalyst running the range of alphabet soup, I can't do anything about that, right? And even if I'm in the same VLAN as them, the only traffic I'm going to see is broadcast and multicast, which gives me nothing. I don't really see what's happening between these clients, right? So how do you kind of tap into that? What virtually every modern switch gives you the ability to do is mirror a port, or Cisco calls it span, or RSpan. Virtually everybody's going to do it, whether it's Mikrotik, Cisco, Juniper, Brocade, Arista. Everybody's going to allow you to mirror traffic, right? So what you can do with a Mikrotik is mirror to just an unlabeled Ethernet port. Don't put any DHCP clients on it. Don't have IPs. You just mirror over to that, and you can torch or packet capture that traffic. So a quick example of that is right here. There it goes. It's going to fire off. Excellent. So this is a Cisco switch I have on my desk. You guys have stacks of gear on your desk, right? So I'm just doing a monitor session. That's how you configure a span in a Cisco device. So you give it a source interface. In this example, my server happens to sit on gig 1.1, telling it both directions. I want to see bidirectional traffic, what it's sending and what it's receiving. I'm telling it to dump it out gig 148. Ether 3 on this Mikrotik plugs into 148. So I can go Tools Torch, and I can choose that Ethernet interface, and then I'll remember to add protocol and port for a little bit more depth than what I'm seeing. Tell it to start. And there you have it. I'm just doing pings. It's just really just ICMP traffic. But you can see the bidirectional ICMPs moving through there. But you can go one step further, which is a little bit more interesting. So beyond just seeing, yeah, that something is moving, I can actually do those packet captures. So I can truly get kind of vision into what's happening. So in here, I'm just pretty much leaving everything default. I'm going to go over to the filter. I'm not actually capturing the packets right off the bat. I just want to look at them. So I'm going to tell it ICMP, right? You want to narrow these down as much as you can just to keep the captures as small as possible, right? If you're capturing absolutely every bit of traffic and it's moving a gig, that's going to put a lot of stress on the Mikrotik trying to capture all that stuff. Once you do, you can hit packets, and you can actually open up those packets inside the Mikrotik itself. So I can look at all the source destination information, I can look at the IP, the header, and actually some of the gibberish that's in the packet itself. As David told you guys, if you make a change, you always have to remember to hit apply first and then start. It's just a quirk of this. So in this example, I'm going to actually capture the packet itself on the Mikrotik. I'm going to call it bad ICMP. I don't know why I called it that, but I did. Apply it. And there's also a streaming option. So theoretically, I can grab all this sniff traffic and immediately stream it off to another device to do collection. So by default, if you just save it as a file, it drops into the file list. You drag and drop it on your desktop, and you open it up in Wireshark to disassemble it and look at it, right? So David was giving an example earlier of SIP traffic, and you could do that, right? That same SIP traffic, you're going to see the bidirectional communication coming from that server. Or RDP traffic, right? If it fundamentally seems like your developers are having an application problem and it's not your problem, this is going to give you the ammunition to be able to say, hey, this is what I see moving across the wire. Everything looks clean. I'm dumping out this port. This is what it looks like. So it's coming in and it's leaving in these exact methodologies, right? You could tell I'm used to having to white paper people a lot. You know, it's evidence gathering. Give them as much as you can. Give them the fire hose, right? Something else with this, spans, mirrors, you can also do R spans for virtually every manufacturer, or remote span. So the idea is server 1 here is connected to switch 1, and then the test client is actually on switch 2 while my Mikrotik happens to hang off of the core switch, right? So theoretically, you could centralize that guy. He's off this core switch, and you create a special VLAN that actually doesn't do MAC learning, so it will dump all the traffic out. So I can do my capture on switch 1 and have that dump out of switch 3 to my Mikrotik. So theoretically, instead of having to have somebody move cables around all over the place, I can just do some switch configuration changes and it can be stable. So this Mikrotik can be put in place in a customer that's 100 miles from you, and you never actually have to go and move it. You don't have to call them and ask them to change cables around. It gives you a little bit more flexibility in those scenarios. And I've done this, and it's been successful. It's pulled me out of a couple of jams. All these things have pulled me out of a lot of jams, and helped me get some additional information from ISPs, get a little bit more leverage. Normally they won't listen to you until you can almost unequivocally prove in triplicate that it's not your problem and that this is where it looks like the source of the problems. And so it usually helps. You guys have any questions? I know this was quick and dirty and kind of high level. I was just trying to give you guys some ideas of maybe utilizing Mikrotiks in a non-traditional way.
Okay. Yes, coming.
I just didn't catch the model number you were talking about using as the simulated client in the early examples, the $20.
Oh, like a HAP light.
Oh, okay, all right.
Yeah, man, I've got a stack of those things. I buy them about 10 at a time, and I keep them, and I always have a couple in my bag. I use them in ways that you're absolutely not supposed to. So I think maybe 1 out of 20 actually has the wireless interface on. I use them for things like, they have 4 ports. I wish they had 5, there's never enough. But for 20 bucks, 4-port router on the outside, for high availability, I'll do VRRP between 2 gateway devices, right? So I've got route failover. On the inside, I'll bond the 2 inside interfaces and I'll just do failover, and I'll run to 2 switches. So you can lose any one outside device, any one inside device. So it's a great little VPN concentrator, right? Or, I don't know. I don't want to get myself in trouble. But use them for all kinds of things that you traditionally they want you to use. Mikrotik would like you to use a bigger, beefier router, but when you're in a pinch, there's a lot of these things hidden in ceilings to make something work. I think, say you've got, what if you had a 600-foot run and you needed just something to pick it up and then shoot it back out, and nobody would ever see it or know about it. Somebody told me once is the most permanent solution is a temporary fix. So kind of goes in there, and so they are definitely the Swiss Army knife, Band-Aid, duct tape, baling wire in my arsenal.
Yeah, nice. Any more questions?
Do you use the bandwidth test at all?
Yeah, the only problem with like the HAP lights is their CPU is limited, so you can't get as much kick out of there. But if you're in a high availability environment where you have an SLA attached, right, all you have to have is one delayed failure, right? So if this can get you to resolution 2 hours faster, it's going to be worth putting in 2011 or 3011 or something a little bit more kick. Right, something a little bit more beef. Also, if you're doing those layer 2 packet captures, the more CPU you have, the more packets you can pick up quicker, right? Those port mirrorings, basically what they do is I can mirror a 10 gig interface and jump it into anything. If it starts overrunning your buffers, there's no error correction, there's no pickup, you're just going to be losing those packets, right? So the more CPU you have, the better you're going to be able to do that stuff. That's what I would say to that.
Okay.
But having said that, it's still pretty good for most scenarios.
I was just wondering if you could explain the use of cable test.
Cable test, that's not in the super cheapos. So you're not going to see it at $20, but that's going to be in, I think like the 2011s and some of the bigger stuff. I think it does kind of an electrical TDM or OTDR, but it's not optical. Would that be ETDR, time domain reflectometer sort of thing, to try and find out how far a break is in a cable? I don't know that I've ever really used it much. I think I've tried it a couple times, but not a whole lot. I think that's how it works. I don't know. I'm not 100%. Maybe the guys in the red shirts know for sure. I don't want to lie to people. I think that's kind of how it works.
Okay.
Anybody
Thank
else?
you.
If we have more questions, is there another time we can come back and ask those?
That's a good one. Tomorrow at 10 o'clock, there is a panel that the Brothers Wisp is doing, the blog. The first of its kind, possibly the last. You never know. Depends on what we say. It's basically an AMA, centric around routing-ish. So the idea is you guys ask us questions, and there's going to hopefully be enough brain power where you're going to get different perspectives, different viewpoints, and we're going to try and come up with it off the cuff. I've got a few ones locked and loaded, but it's going to be way more interesting if you guys actually fire questions at us. And Wilson's got free stuff. It's not just whatever lint is in his pocket. It's probably going to be interesting. He keeps Werthers in there. You know how old guys are. It's weird. Yeah. Anything else would be, one more time, come and introduce yourself to us, shake our hands. These guys drink beer. You can buy me a Coke and a smile. But definitely that's why we come here, is to meet you people. You know, we have a decent idea how most of the Mikrotik stuff goes on, or at least I pretend like I do. So my hubris prevents me from viewing anybody else's presentations. There's nothing I can learn from anybody else, obviously. So, yeah. But yeah, definitely come and say hi. And I've probably stammered on enough. I get to moderate tomorrow, so I'm going to be talking a lot. It's going to be fun. Good times.
Okay.
Good.
Thank you. Thank you, Greg.